Alright, welcome back everybody. Today we're going to be doing our first honor problems in this chapter of optics. Alright, so let's get to it. A shiny, perfectly spherical doorknob acts as a convex mirror with a diameter of 10 centimeters. You stand 1.5 meters away from the center of the knob and your height is 1.8 meters. What is your location of your image in the mirror? Okay, especially when the problems get more complicated like this, I feel like it's important to write down important pieces of information. So diameter is equal to 10 centimeters, which tells me that the radius of curvature, since it's perfectly spherical, is equal to 5 centimeters, which tells me that the focal length is half of that, which is equal to 2.5 centimeters. Another thing is, it's acting as a convex mirror, so this should be negative. Okay. Other piece of information. You stand 1.5 meters away. So I'm gonna say distance of object. I want to convert everything to the same thing. I'm gonna do it to centimeters. So 1.5 times 100, 150 centimeters. Your height of object is 1.8 meters or 180 centimeters. Okay, so that's a lot of I think that's everything we know. What is the location of your image? All right, so what we're going to do, we're going to just do the formula we've been doing, 1 over f, now that we know what f is, or focal length, 1 over distance of object plus 1 over distance of image. So we have 1 over negative 2.5 is equal to 1 over distance of object, 150, plus 1 over distance of image. Again, going to put this to the other side and just do distance of image is equal to 1 over negative 2.5. Since we put it to the other side, it's going to be minus 1 over 150. And since we're trying to get the inverse of it, we're just going to put this to the power of negative 1. Alright, so let's see what we got here. 1 divided by negative 2.5 minus 1 divided by 150. And then the inverse of that, and we get negative 2.46. We did everything in centimeters, right? So centimeters. Okay. So what is the location of your image in the mirror? It's going to be 2.46 centimeters behind the mirror because this is negative. Okay. Behind the mirror. Okay. How tall is your image? Okay. Part B. So we first need to find the magnification. We know magnification. A few ways we could do this. Well, actually, only one way. It's going to be negative or minus distance of image divided by distance of object. So we're going to have two negatives. So on top is just going to be 2.46 turned into a positive. Distance of object is 1.5 meters or 150. So let's see what this is. 2.46 divided by 150. And we get around 0.0164. So a lot smaller. This is the magnification, but we're not looking for the magnification. We're just looking for how tall the image is. So the height of the image is going to be equal to 0.0164, which is the magnification, times the original image, which is 1.8 meters or 180 centimeters. So times 180, and we have 2.95 centimeters. Okay. All right. Hope that all made sense. I know that was quite a bit. So if you need to look back, rewind it and just try to watch it again. All right. Moving on. Number 2 and the last one. You're designing a museum display where a 25 centimeter tall model of a dinosaur needs to appear as a 1.5 meter tall creature to viewers. The model will be placed 2.4 meters in front of a spherical mirror. A. What is the required radius of the curvature of the mirror to create this illusion? B. How far behind the mirror will the image appear? Okay, so again, let's write down everything we know. 25 centimeter tall model, so height of object is 25 centimeters. Needs to appear 1.5 meters tall. Okay, so the height of the image needs to be 1.5 meters or 150 centimeters. The model will be placed 2.4 meters in front of the spherical mirror. Okay, so distance of object is 240 centimeters. And we're looking for the radius of curvature. Okay, it seems like we don't have enough information, but there's a few things that we can do. Since we have the height of the object and the height of the image, this could give us the magnification. And at the moment, it doesn't seem like magnification helps much, but let's, in physics, we're trying to find as many puzzle pieces as possible. So let's find the next puzzle piece. Magnification is equal to height of image divided by height of object. Height of image is 150. Height of object is 25. So let's see what we get. 150 divided by 25. And we get 6. So the magnification is 6 times. That's something we could add here. 6. Okay, now that we know that, this can help us find the distance of image. Because we also know magnification is equal to minus distance of image divided by distance of object. So we know 6 is equal to minus distance of image, which we're looking for, divided by distance of object, which is 240. So now we can do 240 times 6. And then we can see that the distance of image is going to be equal to negative. Oh no, sorry. 2 negatives, right? So it has to be a negative. 1,440 centimeters. Okay. Distance of image is equal to negative 1,440 centimeters. Okay. So what is the required radius? So now that we have distance of image and distance of object, what we could do is we could find the focal length. So 1 over focal length is equal to 1 over distance of object plus 1 over distance of image. So we don't know what the focal length is, but we do know the distance of the object, which is 240. And we know the distance of the image, which is negative 1,440. So now, to find the focal length, we just have to find the inverse of this. 1 divided by 240 minus 1 divided by 1,440. And the inverse of that. Okay, so let's do that. 1 divided by 240 minus 1 divided by 40. Inverse. So it should be around 288 centimeters. So now we also found the focal length, 288 centimeters. However, we're not looking for the focal length, we're looking for the radius. Remember, the radius is just 2 times this. So, times 2. And we should get 576 centimeters. Okay. Whew, that was a lot of work for that. But yeah, 5.76 meters or 576 centimeters. B, how far behind the mirror will the image appear? Well, actually, we already did that, so it's going to be 1,440 centimeters. Okay, or 14.4 meters behind the mirror, because we got that negative sign. Great. All right, thanks for watching, everybody. Again, we're going to be doing reflection and refraction next time, so hope to see you with that. Bye.